Hi students, welcome back to Physics with Ashwini. Today we are going to discuss an important topic called apparent weight. But before going for that, we need to understand a small topic called frame of reference because frame of reference is really important to solve the numericals related to apparent weight of a person. So today we'll see this frame of reference first and then we'll see apparent weight of a person and then we'll solve some previous year questions from your NEET papers, okay? So I hope you are clear with today's discussion. So let's jump into the topic. Any idea about this frame of reference? What is this frame of reference? I'm going to write the definition, try to understand it. Frame of reference can be anything or any object with respect to which the motion of other objects can be measured. So what is frame of reference basically? It can be any object or anything with respect to which you will decide the motion of other objects. That means you will decide the state of other objects. So to decide the state of other objects, whether the objects are in rest or whether they are in motion, to decide that you will take some reference. You will take some object under reference. That is your frame of reference. We'll see one example to understand this frame of reference. Let's take a car. This is the seat where two people are sitting. So let this be Anusha and let this be Arjun. Okay. Now imagine there is a chair here. Let this be Kamala. So there are three people here, Anusha, Arjun and Kamala. Okay. So what we will do is we will take Arjun as the object under consideration. We'll take Arjun as object under consideration. That means we have to decide the state of Arjun here, whether Arjun is in state of rest or state of motion, that we have to decide here. And for that, we are taking two observers here. First observer is Anusha and second observer is Kamala. They are seeing the state of Arjun here. Now it's very easy, very clear that with respect to Anusha, what is the state of Arjun? With respect to Anusha, what is the state of Arjun here? So with respect to her, Arjun is in rest state, right? Because there is no change in position of Arjun with respect to Anusha. There is no change in position of Arjun with respect to Anusha. What does it mean? It means Arjun is in rest condition. That means with respect to the observer Anusha, Arjun is in rest. Now with respect to Kamala, say the car is moving in forward direction. But whereas if you see Kamala, she is sitting on the chair and she is observing the moving car. So car is moving forward with some acceleration. So what is the state of Arjun with respect to Kamala now? So with respect to her, with respect to Kamala, what is the state of Arjun? Arjun is in motion now. That means object under consideration is same. See, you are seeing the state of Arjun itself. Object under consideration is same, but observers are different. So with respect to different observers, we are seeing different states for Arjun. With respect to Anusha, he is in rest. With respect to Kamala, he is in motion. So what does it mean? It means that always motion is relative. Always motion is relative. That means the motion, whether the object is in motion or rest, that depends on the observer and his location or her location. You see, if you see Anusha and Kamala, their locations are different. If I take Anusha, Anusha is in car, right? Now this is your frame of reference. Car is a frame of reference. Where is Anusha? Anusha is inside the car, and with respect from the car, she is making her observation. So from where she is making observation, what is the reference point to her? Car is a reference point. She is sitting beside the Arjun. She is also sitting on the chair. She is also inside the car. So now car is a frame of reference. So the object with respect to which the motion of other objects can be decided. Now Arjun is in rest condition with respect to the car. Now car is a frame of reference here. Anusha is a observer. Now if you see Kamala, she is sitting on the chair, right? Now this chair is also a frame of reference. That means with respect to chair, Kamala, who is the observer, so with respect to her, Arjun is in motion now. So what is this car and chair now? They are the objects with respect to which the motion of Arjun is decided here. I hope you got this point. Arjun is the object under consideration. First point. Anusha is the observer. Kamala is also the observer. Two observers. And the observers are making their observation from different objects. Anusha is making her observation being inside the car. And Kamala is making her observation sitting on the chair. Now, what is this car and chair? These are the objects with respect to which the observers are making their observation. So, this car and chair now they are called as what? Frame of reference. I hope you have understood the definition now. So, any object with respect to which the motion of other objects can be measured. Clear? Now, there are two categories of frames of reference. Number one, inertial frame of reference, and number two, non inertial frame of reference. So, what is this inertial frame? Any frame which is in rest condition, that means it is not moving, or any frame which is moving with constant velocity. Either it should not be moving or it has to move with constant velocity. Constant velocity means what about the change in velocity? Zero. Then what about the acceleration? Acceleration is also zero. So any frame whose acceleration is zero, it's called inertial frame of reference. Opposite to that, any frame which is having some acceleration, here acceleration is not equal to zero. That means the velocity is changing. Either the speed, the velocity will be increasing or it will be decreasing, but it is not constant. The frame will have some acceleration here. This is important point. Third one, Newton's laws of motion, they are valid in inertial frame of reference and they are not valid in non-inertial frame of reference. This is very important. We have seen Newton's laws, right? Newton's first law, second law, F is equals to ma. So they are valid for inertial frames of reference, whereas they are not valid for non-inertial frames of reference. This point is very important because the first thing that you have to do is you have to identify what kind of frame of reference it is, and then we will decide how to solve the given problems. So clear with this? Let's take the previous example itself. We have two frames of references here, right? So car is a frame of reference and chair is also a frame of reference. How is the chair? Is it moving? No. Chair is not moving. So this is what kind of frame of reference? Now I can call chair as inertial frame of reference because this is not moving. Whereas if you take car now, it is moving with certain acceleration A. So I can call this car as non-inertial frame of reference because it is possessing some acceleration. So I hope you are clear with this inertial and non-inertial. Inertial means frame of reference is not moving. Even if it moves, it will be with constant velocity. Acceleration will be zero for inertial frame of reference. Clear? Now, we'll see this pseudo force. Like you may get a doubt. You should get a doubt actually. For inertial frame of reference, Newton's laws are valid. There is no problem at all. We have seen lot many problems in the previous classes, right? Like, taking F is equals to ma, we have seen lot of problems. But if it is a non-inertial frame of reference, if Newton's laws are not valid, then how do we do the problems? What is a procedure? What is a methodology for simplifying the problems? So the answer is pseudo force. Pseudo force is not a real force, but this is considered. Why this is considered? This is considered only when observer is in non-inertial frame of reference. So when observer is in non-inertial frame of reference, only then we consider this pseudo force. And how we have to consider, see, pseudo force in the sense imaginary. In reality it won't exist. We are just considering it to simplify the problems. So let's take the car again. Okay. So the car is moving with acceleration a meter per second square. Now let us take the observer inside the car. Now, where is the observer? Inside the car. How is the car? Car is having some acceleration. So, what is this car now? It's an example of non-inertial frame of reference. So, that means the situation is about non-inertial frame of reference. So, what we have to do? So, generally think this once. If car is having acceleration in forward direction, where will be the force also? Generally, force also will be in the forward direction. F is equals to ma, right? This is a true case. But what do we do here? Since it's a non-inertial frame of reference, as the observer is in non-inertial frame of reference, we consider the force in opposite direction. F is equals to ma. We consider it in opposite direction. In reality, it won't be in opposite. Force is always in the direction of A. But here we are contradicting it and we are taking it in opposite direction. And that is why it is called pseudo force. FPS. Got my point? So, pseudo force is an imaginary force which is taken in the opposite direction of acceleration. If A is forward, pseudo force will be backward. So, this is the important point. First, we'll consider pseudo force and then we will apply Newton's laws of motion. When we do problems, you'll understand this. So far clear? There is one important case. So, let this be the car. Imagine a bob is suspended from the roof of a car. So car, which is a non-inertial frame of reference, moving forward with a meter per second square. Now, if the car suddenly starts moving, how will be the displacement of the bob? It will move backward, right? And it will make some angular displacement theta. So how will you find this theta? So we'll consider pseudo force and we'll simplify this. So since car is what? Non-inertial frame of reference, opposite to A will take a pseudo force and that is equals to M into A. Now for the bob, what will be acting downward? Its weight, that is M into G. Now to find theta, we'll use trigonometric function tan theta, which is opposite to theta by adjacent side to theta. So what is opposite to theta here? This is the opposite side, which is nothing but pseudo force, and this is the adjacent side, which is nothing but the weight of the bob. So just substitute here. Pseudo force is m into a, and adjacent side weight is m into g. So mm gets cancelled, you'll get a by g. So tan theta is a by g, and what about theta? It is tan inverse of a by g. So remember this. And what will be the acceleration of the car? For suppose they'll give you the angular displacement, they'll give you the theta value. How do you find acceleration of the car here? It's nothing but g into tan theta. A is nothing but g tan theta. Clear? So pseudo force is actually important when you deal with non-inertial frame of reference. Okay. Hmm. So this is our main topic of today, apparent weight. Apparent weight of a person in lift. There are three cases here: lift moving upwards, lift moving downwards, and lift not moving at all. So, when you see the first case, lift is moving upwards, upwards or downwards, lift is moving, and the person is inside the lift. So, where is a person? In the lift. And how is that lift? Lift is moving actually. That means the lift is having some acceleration a meter per second square. That means it's a non-inertial frame of reference. So let this be the lift. The person is inside the lift. Lift is moving upward with a meter per second square. Now let us try to apply the Newton's laws. How can we apply? The person's weight mg will be acting downward and the normal reaction will be upward. And as it is a non-inertial frame, what do we do? Opposite to the A, will take a pseudo force, which is m into A. This is your pseudo force. Now just apply the Newton's second law. F net is equals to ma, or upward forces is equals to downward forces. What do you get? N normal reaction is equals to mg plus ma. So if you take out m common, you will get n is equals to m into g plus a. So this normal reaction is nothing but the apparent weight. What is apparent weight actually? It's the normal reaction acting on the person. So normal reaction which is acting on the person, that itself is the apparent weight. Now if you see here, what is the true weight of the person actually? True weight of the person is mg. This is the actual weight of the person. But what is the weight felt by the person when he is in the lift moving upwards? He is feeling extra weight ma. Are you getting my point? You just consider the real life scenario. When you are moving in a giant wheel, when the giant wheel is moving upward, you will feel heavier. Similarly, when you are in the lift, when the lift is moving from ground floor to fifth floor or some upward floors, you will feel heavier. Why do you feel heavier? Because of this additional weight ma. Your true weight is mg. But when the frame of reference is moving upward, you will feel some additional weight. That is because of pseudo force ma. So due to this additional weight ma, you will feel heavier. Got my point? So this is very important. When lift is moving upward, you will feel heavier. Why do you feel heavier? It's because of the extra ma part. So this formula important, this conclusion is also important. Now we'll see the opposite case. This time lift is moving downward. So lift is moving, person is in the lift. So lift is a frame of reference and that is moving downwards. That means it has some acceleration. So what kind of frame of reference is it now? It is non-inertial frame of reference. And how is the lift moving? It is moving downward. Downward with a meter per second square. Person is inside the lift. So we'll apply the same concept. Weight of the person will be acting downward, that is mg. Normal reaction will be upward. And opposite to A, we'll consider pseudo force, which is m into A. Now what will be the equation? N plus ma will be equal to mg. So what is normal reaction now? It is mg minus ma. So take out m common, what will you get? M into g minus a. So this is the apparent weight of the person. So what is apparent weight? As I told you, it's nothing but the normal reaction acting on the person. So here normal reaction is m into g minus a. So when the lift is moving downward, how do you feel actually? You will feel lighter. When the giant wheel is moving down, you will feel lighter. When the lift is moving down, you will feel lighter. Why is it so? Because mg is your true weight. This is your actual weight. This is the weight that you have to feel actually. But how much are you feeling when you are in the lift which is moving downward? Your true weight minus something. You are deleting ma here. You are deleting something from your own weight. That's why you will feel lighter. Got my point? So what you have to understand is, from this, when you are in inertial frame of reference, you will feel your actual weight. But whenever you are in non-inertial frame of reference, you will not feel your own weight. Either you will feel heavier or you will feel lighter. And that depends on how the frame of reference is moving. If the lift is not moving, imagine this. Lift is not moving. That means acceleration of the lift is zero. So when acceleration is 0, how do we consider this lift now? It's a inertial frame of reference because acceleration is 0 now. So when acceleration is 0, when it is inertial frame of reference, there is no point of considering pseudo force. Directly we will apply Newton's laws of motion. So downward we'll have the person's weight mg, and upward we'll have normal reaction. So what is the normal reaction now? Mg. And what is the apparent weight? That is also mg. That means the person will feel his actual weight when lift is not moving. Got this point? Conclusion is very important. So if you take the concept of apparent weight, when you take inertial frame of reference means the frame of reference is not moving. Then what will be the apparent weight? It's nothing but the actual weight of the person. He will feel his actual weight, okay? But whenever the person is in non-inertial frame of reference, then you have to see whether it is moving upwards or downwards. If it is moving upward, if the frame of reference is moving upward, the person will feel heavier. That means he will feel more than his actual weight. If frame of reference is moving downward, he will feel lighter. Giant wheel is the best example. Lift is also, compared to lift, you will feel much, you will experience this very clearly when you are in a giant wheel. Giant wheel moving upward, you will feel heavier. When it is moving downward, you will feel lighter. Why is it so? It's because of this apparent weight concept. Imagine your actual weight is 50 g, mass is 50, and weight is nothing but m into g, so 50 g. You will feel heavier in the sense what? You will feel more than 50 g here, maybe 70, 80, like that, depending on the acceleration of the frame. Here acceleration is 0 and here acceleration is not 0. So depending on the acceleration of the frame, you will feel, accordingly 70, 100, whatever it is. Lighter in the sense less than 50 g, maybe 30, 40, again depending on the acceleration value. So this is important, remember this. And remember these formulas also, because we have some problems. We have some PYQs from your NEET exam based on this apparent weight. If you are clear with the formulas, we'll do the questions. So when frame of reference is moving upward, you will feel heavier. And what is the normal reaction? It is mg plus ma. First formula. When frame of reference is moving downward, you will feel lighter. And what is the normal reaction or apparent weight? Mg minus ma. If it is an inertial frame of reference, then the apparent weight, normal reaction, actual weight, all will be the same. So I hope you are clear. We'll do the problems now. A person of mass 60 kg is inside a lift of mass 940 kg. So what is the total mass here? Person mass is 60 and lift mass is 940. So total it is 1000 kg. Presses the button on the control panel. The lift starts moving. So lift is moving. So this is which frame of reference? This is non-inertial frame of reference. And the lift is moving upward with the acceleration 1. So what is the acceleration of the lift here? 1 meter per second square. And g value is given. Even if it is not given, you should remember. The tension in the supporting cable. So tension in the sense what? It's nothing but normal reaction only. So when the lift is moving upward, what is the normal reaction? It is m into g plus a. We feel heavier because of the additional weight ma. So just substitute. M is 1000 and g value is 10, a value is 1. So 11 into 1000, it is 11,000 newtons. So this is the tension. See how easy the problems are. Just you have to remember the concept and memorize the formulas. The mass of a lift is 2000 kg. So mass is given. This is 2000. When the tension in the supporting cable, see tension, normal reaction all mean the same. How much it is? It is 28,000 newtons. Then it's acceleration. So we have to find the acceleration of the lift. What is the normal reaction? That can be taken depending on the case, whether it is moving upward or downward. But the direction of motion of the lift is not given in the question. See the options: upwards, downwards, upwards, downwards. That means you have to verify every option one by one. So first, let us take option A. What is the direction of motion? Lift is moving upwards. So just consider lift is moving upwards. So what will be the formula for normal reaction then? Mg plus Ma, right? So normal reaction is how much? 28,000. Mass is 2000 and G value is 10. So mass is again 2000, A value we don't know, we have to find. So just simplify this, how much will you get? So 2000 A is equals to 8000. And what is A now? Three zeros cancel. It is 4 meter per second square. So when the lift is moving upward, we got the acceleration as 4 and that was given in the option A. So this is a right option. We started verifying the options and the first option itself came as the right answer. One more problem. A man weighs 80 kg. So mass is given 80 kg. He stands on a weighing scale in a lift which is moving upward. So lift is moving upward now. And what is the acceleration of the lift? It is 5 meter per second square. What would be the reading on the scale? Reading on the scale. So reading is nothing but what again? Normal reaction. So lift is moving upward. What is the normal reaction formula? Mg plus Ma or M of G plus A. So M is 80, G is 10, acceleration is 5. So 15 into 80, 15 8 is 120, extra 0. So 1200 newtons. See how easy the problems are. Just based on formulas, direct formulas. A monkey of 20 kg is holding a vertical rope. The rope will not break when a mass of 25 kg is suspended from it. But it will break if the mass exceeds 25. That means this is a rope. The rope will not break if the maximum mass attached is 25 kg. If you attach more than this, then it will break. That means what is the maximum tension supported in the rope? It is 25 into G. Because what is the maximum weight here? 25 into G. It will support this 25 G weight. More than that, it will not support. So you got the tension value. Tension is 25 G. If you see the monkey mass is 20. That means it is less than 25 only. So rope will not break. So this time we have a monkey whose mass is 20 kg. How much is the tension in the cable? It is 25 G. We have calculated it from the given question data. Okay. So what is the maximum acceleration with which the monkey can climb up? See, what is the direction of motion of monkey? Monkey is trying to move up with some acceleration A. What is that? We don't know. That we have to calculate. So downward weight of the monkey is 20 G. Now just simplify this. Monkey is moving upward. So what will be the normal reaction or what will be the tension in the rope when it is moving upward? It will be mg plus ma. So normal reaction is 25 G. That is nothing but tension in the rope. M into G, mass of the monkey is 20. So 20 into G plus 20 into A. So what will you get? 20A is equals to 5G. 5 ones, 5 fours. So you'll get A is equals to G by 4. So 1 by 4th of G is what? 2.5. So what is the answer now? It is option D. Don't take the tension as 20G here because what is the maximum tension that is supported by the cable? It is 25G. Instead of directly giving you the value of normal reaction, they just added one more sentence in the question. Okay. We'll see another question. A lift of mass 1000 kg moving with acceleration of 1 in upward direction. So mass is how much? 1000 kg. Acceleration of the lift 1 meter per second square and this is moving upward. The tension developed in the string. So tension is nothing but normal reaction only. Lift is moving upward. So what will it be? It will be M of G plus A. Mg plus Mg or you take M common, that is also fine. So 1000, G is 10, A is 1. So 11 into 1000, this is 11,000 newtons. Option C. Next, a mass of 1 kg is suspended by a thread. It is lifted up in the first case with the acceleration 4.9. It is lowered in the second case with the same acceleration 4.9. What we need to find? We need to find the ratio of the tensions. So tension, normal reaction all mean the same. As I said earlier, mass is 1 kg. So when the lift is moving up in the first case, what will be the tension? What will be the normal reaction? It is m of g plus a. Second case, when the lift is moving downward, what is the tension? What is the normal reaction? It is m of g minus a. So if you take the ratio of them, let it be T1 and T2. So what is the ratio of T1 by T2? Gets cancelled. You'll get G plus A. So G is 9.8 and acceleration is given 4.9. So G is 9.8. In the second case also acceleration is given 4.9. Can I write this 9.8 as 4.9 plus 4.9? 4.9 plus 4.9. How much you'll get? You'll get 9.8 only. So numerator I can write it as 4.9 plus 4.9 and already 4.9 is there. So this is 3 times 4.9. 9.8 minus 4.9, 4.9. So they get cancelled. What will you get? 3 by 1. So what is the ratio? 3 is to 1. Clear? So this is what for today. I hope you have understood today's class. Very easy. See, you can see how many questions are there from this topic. Apparent weight is important. And if you see all the PYQs, they are almost based on one formula. N is equals to mg plus ma. That means in all the PYQs, they considered the lift moving upwards. So just remember the formula, and if you just substitute it and simplify, it's very easy. There is, not much hard work is required. Just remember the formula, be, smart enough to apply the given data into the formula. That is enough actually. Okay, so this is what for today's class. We'll meet in the next class, and in the next class, I'll discuss Newton's third law and rocket propulsion, and we'll see some PYQs related to that. So do practice. Thank you so much. Have a nice day. Bye bye.